Hi, my name is Jennifer Hay and I'm with eLearning Curve, and today we're here to talk with KY Sue about his work in GIS systems and locational data. Tell us, what is GIS and what does it do?
GIS stands for Geographic Information Systems, and the word information brings up a key point here. GIS deals in data. It's not just a graphics program, and it's far more capable than the data visualization tools that are currently popular. GIS has a relational database capability, and as such it can join and read many existing database and data storage, even data warehouse formats. Thus, GIS is able to give structure to locational data, which is usually considered unstructured data. It applies quantitative analytical capabilities to location to answer your where business questions. The conceptual key to GIS and to making best use of it is that GIS provides, like I said, structure to locational data, both qualitatively and quantitatively. It can compare or query locations of multiple phenomena against each other through the process of thematic mapping, and it can create new data sets combining or synthesizing multiple parameters.
I've always been fascinated by that. Okay, let's look at the next question. So how do mapping and map production work in GIS systems?
Before I go into map production, I'll add that a map might not actually be your final deliverable. Given that GIS is an analytical tool, it's a database, your deliverable might merely be the answer to a query. But usually in order to set up the locational queries, we will need to set up a map.
So that's the foundational starting point then, you're saying?
Yes. The key to GIS's capabilities is that all geographic data is georeferenced. That term basically means all data has a location stored as quantitative numerical data in a standardized scheme, accurate down to the foot, sometimes down to the inch. What that enables you to do is to have multiple data sets, which we call layers or themes, to be aligned with each other with mathematical computational precision. So the key to GIS capabilities is that all geographic data is what we call georeferenced. That means that all the data has a location stored as numerical data in a standardized scheme, accurate down to the foot, sometimes down to the inch. What that allows you to do is to have multiple data sets, we call them themes or layers, to be aligned with each other, and that allows you to query different data sets against each other for your spatial analysis. So there's two basic steps to making a map. First, generally your background reference layers, that's your cities, counties, your census tracts, your roads, the things you're used to seeing in a conventional road map, are usually pre-made. So all you have to do is just load those into your map document. The two common exceptions to pre-made map data that you're going to have are, one, geocoding of addresses. That could be your customers, your store locations, or other pertinent locations. And two, custom created areas. That could be your sales territories, it could be radii, or what we call buffers around specific locations.
So you're using internal data and external then. Where are you acquiring your external data?
Your external data, that would be your base layers, often are available as free downloads from government agencies. Sometimes you'll purchase it, but usually, oftentimes, it's free. Geographic data usually has key fields that are put there for the purpose of joining tabular data to it. To explain geocoding, that's taking address lists and making points on the map from that. And we can do that at high volume. We can run batches up to 1 million addresses, and the software can plot those at rates of tens of thousands an hour, sometimes hundreds of thousands an hour. Makes it much easier to analyze than if you're just, looking at a map pinned up on the wall and trying to figure, okay, that's better zoning, but that's more expensive. How does it balance out?
All right.
We can do that quantitatively in GIS.